Hello friends, today we are going to learn the chapter Electric Current and its Effects. What is an electric fuse? Different types of fuses. An electric fuse is a device that is used to prevent the damage that can be caused by an excess of electric current. According to the heating effect of the electric current, a wire becomes hot as current is passed through it. However, if an excess of current is passed through a wire, it can melt or break. The electric fuse consists of a wire which is made up of a metal or an alloy which has a low melting point. As a result, the wire breaks down easily as high current passes through it. As the wire breaks, the circuit of the fuse opens and hence no further current passes through it. This can prevent a short circuit for fire due to high electric current. Different types of fuses are used for different devices and some are also available for houses as well. How can excessive current pass through a circuit? Reasons why excessive current can pass through a circuit. Sometimes we connect different devices to the same socket, which results in drawing off more current from that socket. As a result, the load on the circuit increases and it can lead to a short circuit or fire. When the insulation of wire gets torn away, the wires can come in contact with each other, which causes spark or may lead to a fire or short circuit. This is why fuses are used to prevent any kind of short circuit and overloading. CFL bulb, compact fluorescent lamp. CFLs do not work on the heating effect of electric current. They do not have a filament inside them. Instead, they contain two electrodes that produce light. These bulbs have a fluorescent coating inside them, which makes the light brighter. CFLs thus save energy as they do not produce heat along with the light. Ordinary bulbs, on the other hand, waste energy as they get heated while lighting up. What is an ISI mark? ISI stands for Indian Standards Institute, which standardizes all electrical appliances. Hence, if any appliance does not have an ISI mark over it, it means that this appliance does not conform to the standard guidelines of ISI and hence it is not safe to use. On the other hand, if any appliance holds such a mark, it means that it is safe to use. It is a quality product and it will not lead to wastage of electricity. ISI mark on electric geyser. What are miniature circuit breakers? MCB. A miniature circuit breaker or MCB is generally used instead of fuses. A fuse breaks due to excessive current so that the circuit opens up and the damage can be prevented. However, once a fuse breaks down, it cannot be used again. MCB, on the other hand, is a switch which turns off on its own when a circuit overloads. Once the circuit is rectified, we can switch on the MCB once again. Magnetic effect of electric current. When an electric current is passed through a wire, it behaves like a magnet. This is called the magnetic effect of the electric current, which was discovered by a scientist. Hans Christian Ørsted. He discovered that the needle of a compass deflects when an electric current is passed through a wire placed near the compass. This indicates that a magnetic field is created near the wire that deflects the needle. Magnetic compass needles. Electromagnet. Every magnetic material has a magnetic field up to which the influence of its magnesium can be experienced. A magnet whose magnetic field with the help of electric current is called an electromagnet. The electromagnet is formed because of the magnetic effect of the electric current. Electromagnet. Electric bell. Components of an electric bell. A coil of wire wound over an iron piece that forms the electromagnet. An iron strip. Soft iron armature which has a hammer attached to it, which is joined to the wire coil. A contact screw through which is attached to the iron strip. A battery which connects the wire coil and the contact screw. A switch in the middle of the circuit. Working of an electric bell. When the switch of the bell is on, an electric current flows through the coil of wire which makes the iron piece attached to it act as an electromagnet. As a result, the iron piece attracts the hammer towards itself. The hammer thus hits the bell and a sound is produced. As the hammer moves towards the iron piece, it moves away from the contact screw which breaks down the circuit. As the circuit breaks, the wire coil stops receiving any current which makes the electromagnet lose its magnetic effect. As a result, the hammer falls back to its original position. Then as the hammer falls back, the iron strip again comes in contact with the contact screw and the circuit gets completed. This again turns the iron piece into an electromagnet and the whole process continues until the bell is switched off. This results in the continuous ringing of the bell. Thank you, friends.